way you laugh with your mouth closed, the way you smile so your eyes glow. It's in the way you look at me so I can see just who I am inside. The way my heart doesn't listen, and so it just keeps wishing you were close to me so that its beat was synchronized with yours.
Ai, peta apa ni? Duk. Tak, ni surat cinta aku. Tak ada surat cinta ada aku. Aku malu. Aku malu je. Kacau lah dah ni. Kali ni aku share. Lepas jalan kita ni, kita dah dekat atas ya sekarang ni. So maybe tanda X ni ada sebelah tasik lah. Yes. So dekat kau pasti dia tasik ni kat sini. Yes. Ini. Tak serius, betul. Serius, aku video. Dia try tengok dulu. Lepas tu sekarang kita kena naik tangga tiga. Kat dua, lepas nanti kita dia akan jumpa satu bilik lah. Yang rasa itu dia punya location. Atas sini lah location main. Tapi mana tu? What's this? You can see what inside. What is this, man? Catalyst one. Progress statement.
Izhan! Izhan! Weh, macam main game je kau? Saya lepas semua sama.
Betul.
Baik kau tolong kita orang.
Kita nak solve ni. Copy catalyst. Apply maximum and minimum solving.
Oh, senang ini. Nanti jom. Aku tolong.
Let's go.
We have two problems here. Which one should we solve it?
I think we should look at the map.
Map.
Yeah, this is the map.
We found the treasure from the map.
Is there any clue here?
Let me see.
Wait.
There is.
Your key is
Your
one.
key is one.
So maybe
I think we should solve the problem with statement one.
Okay, let's solve them.
Differentiation is a process in math where we find the instantaneous rate of change in function based on one of its variables. The most common example in this rate change of displacement with respect to time, called velocity. The opposite of finding a derivative is anti-differentiation.
We have few derivative to find the maximum and minimum of some function given by equation. But it is very unlikely that someone will simply hand you a function and ask you to find its extreme value. More typically, someone will describe a problem and ask you in maximizing or minimizing something. For example, what is the largest volume package which the post office will take? Usually, this problem has some restriction and constraint on what is allowed, and sometimes neither the problem nor the constraint are clearly stated. So the first step, write an equation that describes the situation, such as an equation that tell you how to calculate the time it will take to cross a river. And then the second step is take the derivative of your equation. So the third step is set the derivative equal to 0 and solve for x. This will give you the point along the original equation where the curve is turning, such as the bottom or top of parabola. On the original curve, this will be the point where the curve was increasing and now begin to decrease, maximum, or the curve was decreasing and now begin to increase, minimum. Fourth step is take your answer from the step number 3 and put back into the original equation and solve for y. And then you will get the maximum or minimum. So the last step, the fifth one, to determine whether it is absolute max or absolute minimum or local maximus and minimum. If the original equation is simple, just sketch to see it.
First of all, the question give volume of cylinder is 600. So we use the volume of cylinder formula, which is pi r square h, and we can equal it by 600. So we move pi r square to the right side and we get the value of h, which is 600 divided by pi r square. Then we use the formula of surface area of cylinder, which is 2 pi r square plus 2 pi r h. Then we enter the value of h back to the formula, and the result is 2 pi r square plus 1000 and 200 divided by r. So we will get the same surface area that the question asks. Step 1 is find the derivative. We're gonna use the equation we get from question A, which is A equal to 2 pi r square plus 1200 r to the power of negative 1. And then we're gonna differentiate the equation. So the power of r will be multiplied with the front number, and and it will be dA over dr equal 4 pi r minus 1200 r to the power of negative 2. And then we're gonna move the r back below the 1200, and it will be 4 pi r minus 1200 divided by r the power r square. So step 2 is let the derivative equal to 0. We're gonna let dA over dr equal to 0, and we will get 4 pi r minus 1200 over r square equal to 0. Then we're gonna move 1200 over r square to the right side, and it will be 4 pi r equal to 1200 over r square. Then the r square will move to the left side and it gonna multiply with 4 pi r. So it gonna be 4 pi r cube equal to 1200. So we get the value of r cube, which is 1200 over 4 pi. And then we're gonna move the power of 3 to the right side, and it will gonna be r equal to square root of 3 1200 over 4 pi, and we will get the answer, which is 4.57 cm. Then step 3 is second derivative test. We're gonna differentiate the equation again, which is dA over dr equal to 4 pi r minus 1200 r to the power of negative 2. So it gonna be d square a over dr square equal 4 pi plus 2400 r the power of negative 3. So r the power of negative 3, we're gonna move back below 2400. So when r equal to 4.57, we're gonna enter the value of r back to the equation, which is d square a over d r square equal 4 pi plus 2400 over 4.57 the power of 3. The answer is 37.71 more than 0. So r equal to 4.57 cm is a minimum value. Then when r equal to 4.57, we're gonna use h equation back, which is h equal to 600 over pi r square. Then we're gonna enter the value of r back into the h equation, which is h equal to 600 over pi multiplied by 4.57 the power of 2. So we're gonna get the answer is 9.14 cm. We're gonna use the equation a back, which is 2 pi r square plus 1200 r the power of negative 1. We get the value of r, so we're gonna enter the value of r to the equation a, which is 2 pi multiply 4.57 the power of 2 plus 1200 over 4.57. So the final answer is 393.81 cm square.
In summary, the study of maximum and minimum problems in Calculus 1 provides tools for optimizing real-world situation, such as by finding critical points and using optimization techniques. We can determine optimal values and make informed decisions. This knowledge of applicable across various fields and develops problem-solving skills. Calculus 1 serves a foundation for further exploration in high-level mathematics and beyond.